We're gonna wash these. Washing them.
Wash. Nada.
Oh, no, Gogo, wait. Do you want to burn this house?
What do you mean?
Metals are not supposed to be in the microwave because they will blow up or start a fire.
Een bietjie meer versigtiger wees, Mvuko.
That is as Devi. I didn't think anything would happen.
Die teelepels van staal gemaak. As dit verhit kan hy die mikrogolfoond beskadig en ook die kos vermors.
Oh, wow, thanks, guys.
Mvuko, you cannot put metal in the microwave. It will get heated up and cause a fire.
Then what about the metal layer of pies? Why doesn't that cause a fire?
Well, come closer, let me explain to you. Listen, some microwavable products like soup and pies are packaged in a very thin metal layer under a non-metal lid. So the food that is trapped along the metal browns nicely and quickly. But if you leave those snacks in the microwave for a few minutes longer, they can incinerate as well.
Microwaves are a form of electromagnetic radiation, like radio waves. They are generated by a device called a magnetron that pulses back and forth rapidly in an oven.
Ing or ring?
Talk about bombastic words. You're such a techno-whiz, Vian.
Yeah, that he is. I also got lost for a moment just there. But Mvuko, remember, you must also be neat how Kenya dijo in the microwave.
Kumele ukudla kwakho kahle or else kuzochitheka.
And remember, leave the microwave as clean as you would like to find it in.
Gogo, isalele nkimo belalela mara ha retsi.
Oh, really now, Marang?
Ons moet netjies bly, ouens. Eerste indrukke is blywend.
Point taken, guys. From now on, I will now do so. Gogo, come up and go.
Okay, guys, let's go into the wonder room.
Let's go.
Door to everything and everywhere. Open up and take us there.
Okay, guys, let's have a look at metals.
Hello, my name is Andries Breitenbach. This is my colleague, John. We are from Ekurhuleni Art and Skills and Training Center. The new section we're going to start now is about metal. Where does metal come from? That's where we get the mines from. The guys go in the mine, go down in the ground, we take out the rocks, so they crush the rocks to a fine powder, and when they crush the rock to fine powder, they heat it up and they get the metal out. So for iron, for steel, this is a ferrous metal, but this metal is not pure. Iron is the pure metal for steel. This is a combination of tin and copper and iron and coal. So without that stuff, you will not get this type of material.
In the mines, they dig a stone. That stone, they call it, it's an iron ore. Then it needs a temperature of 1000 degrees Celsius in order for that stone to crack to be a powder.
But now if we get to copper or aluminium, is also mined from the ground, but it comes directly out of the ground and we use it directly. We just form it into a certain shape and then from there we're using it. So there's no substance thrown together to make it look different or make it harder or whatsoever. Brass is a substance of copper. You'll see copper is red or brown. Brass is yellow. The yellow color is formed because they throw a 0.5% tin to the copper. And when they mix the two, they find brass. Why they want brass? Brass is slightly harder than copper and stronger. You can see they make a valve from it, and that is just a little pipe.
And we have two types of material. We have a ferrous material and non-ferrous material, and mild steel falls under ferrous material and copper falls under non-ferrous material. Ferrous material are the materials that contain iron and they are rusting. Copper is a material called non-ferrous, is not rusty. As I was talking about ferrous, ferrous are magnetic. As you can see, the magnet is touching. And brass is non-ferrous. You see the magnet is not touching, it's falling. And also copper is falling under non-ferrous. The magnet is not touching, it's just flow. Also aluminium is not ferrous. The magnet is not touching, it's flowing. And the importance of knowing the material is to show that you can use which material where and where. You cannot use, when you work with food, you must use non-ferrous material, the material that are not rusting, so that you cannot get food that is rusting. Like pots, pipes, in the factories where they manufacture milk and yogurt, they use stainless because stainless is not rusting.
Millability. Millability is a plate covered with galvanized. So if I take this plate and I bend it in any direction, it stays like it doesn't break. Yes, eventually, if I continue, then the metal gets exhausted and then it will start breaking. But it doesn't break. It will take quite a while before it breaks.
Ductility, that characteristic is linked to mendability, but what is different there is that this one you cannot bend it with hand. You need hammer, you can hammer it, or you can bend it with a plier, or you can heat it and bend it like gold and copper. By bending it, you are not damaging the material. It's also bent, you can take it back to where it was.
Non-ferrous metals like gold and silver and copper is something that you don't have to heat it physically up to change the characteristics of it. When they're making a ring, they got a little mold where they throw in your shape you want, and thereafter they can hammer it to make it more tense and more heavier.
And that material is not rusting, that's why it's falling under non-ferrous material. They are not containing iron.
The boiler making and the metals that's involved in boiler making. So what we got here is a boiler. Boiler is for us to using hot water or generate electric power in power stations. So what we got here, going to say to you exactly each and every part we got here, and then we're going to explain to you how it works. First we got a supply tank. Supply tank got an amount of water inside. The amount of water is cold and always needs to be full. From that point, we got a little valve down there. So if we need to work on the system, we close the main water supply. So we open the valve. We open the valve. The water will run through, comes through the pipe into the heater. There we got a burner to generate heat. The heat will run up through the exhaust, and then this tank will get hot. So if I feel it, you can feel it's quite hot. Then that water will run through this pipe, hot water, goes back into the tank. Now this system is exactly the same system we're using in our house. There we got a T-piece. We would have a T-piece down that side where we're going to take the hot water inside for washing or bathing.
When you do the connection, you must make sure that there is no leak, and in that connection in the joints you don't get air, because if you can get air in the joints, then the temperature, it won't be the same, because the air will be going out. The water you won't get, the water won't come up.
The heat of the burner is generate heat. The metal taking up the heat because of the molecules, the compound of the metal, and that heat is transfer that heat to the water, and the water is lifting up as it goes back into the tank. So basically that is what the hot water system is about.
Wow, that was certainly insightful.
It was a bit complex if you ask me, but I got it.
Yeah, but Sanele, it is a bit complicated, but it is important for Tukutu. You must learn more and know about it. Okay, guys, a picture is going to appear on the screen, and you are going to tell me what metal it is. Are we ready?
Yes, Gogo.
Okay, let's go. Here's the first picture. Who can tell me what that is? Yeah, but Sanele.
It's copper, Gogo.
Good. Okay, here comes the second one. This one?
That's gold, Gogo.
It's gold. Thank you, Marang. And then here comes the third one. Who can tell me what's that?
Me.
Yes?
That's iron.
Iron. And in color? What's the color of iron? Does it look silver?
I don't know.
Okay. The next one?
That's silver.
That's silver. You see the color of silver and iron nearly look the same, Yeah, but this was a very easy one, guys. Now I'm going to ask you some questions. We're going to have a quiz to see how much more you understand about your metals. Are we ready?
Yes,
Let's go. Yeah.
Okay. Gogo always has these interesting questions. Okay. What is the chemical symbol of gold?
Okay, Gogo, let me tell you wrong. Isn't it AU?
Thank you, Sanele. Here's the second question. True or false? Steel is a chemical element. True or false? Yes, Mvuku?
It's false because alloy is a chemical element.
Yes. Here's the third question. What is the most common metal found on Earth? Oh, Marang.
Gogo, is it iron?
Yes. Okay, here's the fourth question. True or false? Sodium is a very active metal.
Dis baie waar, Gogo.
My Tony, it's not you already answering. You guys, you are really on the ball. Okay. Question 5. What 3 kinds of medals are awarded at the Olympic Games?
Oh,
Sanele.
it's gold, silver, and bronze.
Yes!
Dit was 'n baie maklike een. Jy kan hom so 'n bietjie vinniger gesê.
Yeah.
Okay, guys, here's question number 6. True or false? Metal bonding with metal is known as a metallic bond. True or false? Come on, guys. Eh? Mvuko?
That is true, I think.
Yes, Mvuko, that is true. Question 7. Bronze is made from what 2 metals?
Is gemaak uit koper en tin.
Baie waar. Question number 8. What is the only metal that is liquid at room temperature?
Oh, I know, Gogo.
Yes, Marang?
Mercury.
Mercury. Oy, o nepile. Question number 9. True or false? Sterling silver is made up of less than 50% silver in weight.
That's false, because sterling silver is made out of more than 92%.
Nana. Okay, this is question number 10. What metal has the chemical symbol PB?
PB, atatuziva.
Lena, Gogo.
Guys, try. I mean, I know one of you knows the answer. Please try. Do you want to try?
Ja, ek dink die antwoord is lood. Ek onthou ons juffrou het dit nog vir ons vertel.
Oh, yes, it is lead. Yes. Optical. Okay, guys, let's go over there. I have an experiment to show you.
Okay.
Okay, guys, now that you know about metals, let's learn about chemical reactions.
Chemical what?
Reactions.
Chemiese reaksies in Vuko. Chemiese reaksies is die proses wat lei tot die omskakeling van een groep chemiese stowwe na 'n ander groep.
Oh, I knew that.
Okay,
Yeah,
you
right.
two. Let's start with our experiment. Basically, what we are going to do is we're going to soak steel wool in one beaker in the vinegar, and then we are going to see what happens when the iron reacts with the oxygen around it.
Steel and vinegar. I can't wait to see this.
Okay, Mvuko. We are going to need the following. There's a thermometer here. Can you see it? Lift it up and see it?
Yes.
Yes. Yes. Yes. Remember that takes temperature.
Okay.
Okay? And then we have our vinegar. We have 2 test tubes or beakers. And then we have 2 bowls and our steel wool. And there in Vian's hand, we have paper to cover the lid of the beaker.
Whoa, this is cool.
Okay, let's read our instructions, right? Are we ready?
Yes, Gogo.
Okay, we must first place the steel wool inside the one bowl.
How many?
You can put 1 or 2, it's fine. Okay, and then we are going to soak the steel wool in vinegar. Pour the vinegar into the bowl in Vuko.
Okay.
Soak it, ne? Soak it, Sissy. Soak it. Pour it. Pour.
Almost.
Let it soak. Let it drown in the vinegar. Okay. So we are going to leave it for a minute so that it really absorbs.
Okay. Yo.
Gogo, as the silk absorbs the water, it becomes bigger.
Yes. Can you see that?
The vinegar, sorry, not the water.
Yeah. The liquid, ne? The liquid vinegar.
It definitely doesn't smell like water.
And vinegar has got a sharp smell, ne?
Steel wool is bubbling.
It's got an iron coating, yeah.
It's bubbling.
Can you see it?
Bubbles.
Okay. Now let us remove the steel wool and drain any excess vinegar into this other bowl.
Okay.
Warren Sanale and Maranti that's
Okay.
to them.
Gogo, please repeat.
Let us remove the steel wool and drain any excess vinegar into this bowl. Remove excess vinegar and just drain it. When we are done, we take the thermometer and we wrap the steel wool around the base of the thermometer.
Yeah.
Yes, around the base,
the
yeah.
grey parts.
Just move it here. Hold it.
Oh, there's another. You can
And place them both in the beaker.
carefully.
Careful, guys.
Okay.
There we go.
Now let us cover the top of the beaker with that covering, with that sticker there.
Steel wool and just put it there.
Put another sticker there.
That's
Let's see.
There's no air coming through. There we go.
Let's see.
little bit of air.
You're going to wait for something like 5 minutes or so and see for a reaction, wait for a reaction and see what happens the inside there.
Ek kan nie wag om te sien hoe die finale resultate gaan wees nie.
When we soak the steel wool in vinegar, it removes the protective coating of the steel wool and it allows the iron in the steel to rust. Rusting or oxidation is a chemical reaction between iron and oxygen. This chemical reaction creates heat energy which increases the temperature inside the beaker.
Gogo, when you smell it, it smells like something that's burning.
Really? Vuko, do you want to try?
Yeah.
Let him Vuko try.
Yeah.
Marang?
You can actually smell it, Gogo.
Whoa. You can literally. Whoa.
You can. You can. You can. Did you feel any heat on the beaker when you touched it?
It's getting warmer.
Is it?
Yes.
What does it say there? The temperature?
100 degrees
Celsius.
Fahrenheit.
Ah, okay. So guys, these are the results we should get when we do this little exercise. Ke solofela gore le ko gae ko le tla dira your own vinegar and steel wool experiment and get your own results. Guys, let's go and finish our homework.